remember from the layers, John?
That there's the inner core, the outer core, and the mantle, and then the crust.
Very good. Okay, tell me more about these, Jalen.
They like the inner core is like the smallest, but it's the hottest. The one in there is made of what's one was made of lava and everything? The mantle is made of lava and stuff, and the crust was us, and we also learned about the plates, the three directions that they move.
Okay, we're gonna go there. Don't get ahead of yourself. Tiana?
About the earth features. We also learned about how the crust was really, really thick, but the mantle was just real skinny, and then how it was so tiny. If we throw the biggest hole in the earth, it would just be like a little crack in it.
So, yeah, our thinnest layer, as we can see by the white, is the crust. But to us, it's really, really thick, isn't it? Remember the brain pop video?
Yes.
He said that you only dug not that far down into the crust.
I wonder how does he think?
Probably took a while, I would imagine.
Well, he's a robot.
And so, Jalen, you were talking about plates. What were you talking about plates for?
Plates, they move in three types of directions. They either move like straight under and over. They move like two ways, one goes this way, one goes this way. Or they both just go into each other.
Okay, good.
And when usually if it causes an earthquake by both of them running into each other.
So this, what is this picture of? What does it show us? Brian?
Where the plates are?
And what are plates?
The crust.
What did we compare the plates to? Dan?
Steak.
Steak? Puzzle pieces. Yes, like giant puzzle pieces that come together. And we were just talking about how the plates move, as you can see in this one. They move different ways, right? Come on in. Oh, hello, happy birthday. You can just put it on my desk, sweetie. Thank you. Alright, so when we talked about seafloor spreading, what happens here? Tiana?
Seafloor spreading is when the two plates are coming into convergence. And what happens is sometimes the land comes under. What it does, the lava rises up, and that's how they create a volcano.
Close, but not totally. What's happening here? What do you notice? Safari?
First they were all together, but then
What was all together?
Africa and stuff like that.
All of the, what do we call those?
Continents.
All the continents, yeah.
And they all broke apart from the inner core.
So you can see right here, this plate is spreading apart from the other plate. And this is seafloor spreading. So the seafloor is getting bigger. Yeah, it's getting bigger. Do you remember what we called the earth when all of the continents were together?
A puzzle.
A puzzle, yes, but there was a word that started with a P, like puzzle. John? Forgot? Tiana?
Pandora.
Close. Jalen, you remember?
I just forgot.
Oscar?
Pandora.
the back. Dakari? Pangea. Pangea, yes. Yeah, remember that was when all the consonants were together, and then this seafloor spreading happened along the plate, and it caused the seafloor to spread apart, and so now we have our wide oceans with deep valleys because of this seafloor spreading. So this is the seafloor. Right here, you can see the mantle coming up and spreading the seafloor apart as this plate dips into the other plate. So that's seafloor spreading. That's different than the transforming, than the divergent and convergent plates. Let's see if you remember the hand motion. Two hands.
Oh, I know it all.
Show me transforming plate. Isaiah's got it. Where they rub together. Oh, sorry. Show me divergent plate. Frances has it. What do?
Away from each other.
Spread apart. Yeah. Show me convergent plate. Dakari's got it. What do, Dakari? They come together. They come together. So, if we go to divergent plates, you can see the two arrows, they spread apart. And if we go back to our diagram, no, it didn't work this morning. We can see what's happening when plates diverge. What forms? Deanna? Ocean floors.
More land.
Yeah, more land forms. Ocean floors get bigger. So you can see here the mantle is melting the crust. It's spreading apart the sea floors. The ocean's getting wider. This is divergent boundaries. Now, convergent boundaries. Show me with your hand. Good. What forms here? Do you remember? Jalen?
When the plates go down, the mantle, like, it melts it, and then it comes up like that lava.
And so what forms? What land forms?
A volcano.
Volcanoes. So if we look here at our diagram, here we have convergent plate boundaries, and you can start to see what's happening here. I'll do it again. So what's happening? What melts down here?
The crust.
The crust melts and it forms a vent. So here the plate is now entering what part is this? What layer? The mantle. The mantle is melting this crust and it's forming a vent that now forms a volcano. These are two divergent plates coming together. Deanna?
But what does it do when one doesn't go under each other,
And they just come together? What do you think forms?
a mountain?
A mountain, yeah. So Tiana's asking, what happens when one doesn't undercut the other like it is now? Well, what do you think? Look at my hand. What's going to form? A mountain, yes. You get mountains when plates just form on top of each other. You're going to get mountains. John?
Is it how did Mount Everest be the highest mountain if they're just going together and going up?
Because think about it, the plates for so many millions of years have been pushing on top of each other, just causing the rocks to pile up and push the mountain even higher up. Does that make sense?
Yeah.
Jalen?
How do we make that lava come down?
Well, what's down here? What layer?
Mantle.
What's the mantle made of?
Lava
And rock?
Yeah.
And so what happens down here to this plate?
And no.
It melts, and then it starts melting, what's this? What layer? The crust. It starts melting the crust, so it's kind of like a fire that's here. It starts melting this, causing this part to melt, and then it causes a vent where you get volcanoes. Tiana?
What is, like, when we have new land,
Mhm.
what do we do when we get new land?
Well, remember, do we get new land? Am I going to wake up tomorrow and there's new land?
No. Like, how long would it take, like, to have new land?
What do you think?
Millions of years.
Millions and millions of years. They say the Rocky Mountains, we all know where the Rocky Mountains are?
Yeah.
The Rocky Mountains are new. Are they really new? No. But they're new in geological terms because they're probably only a couple million years old. So that means they've been formed after the Appalachian Mountains. So it's not like we're going to wake up and find new mountains outside, right? It's going to take millions and millions and millions of years. It happens very slowly. Remember we talked about our fingernails growing? Can we watch that?
Yes.
We can watch our fingernails grow?
No.
If we have a videotape on them constantly, but we can't watch our fingernails grow. And land moves even slower than that. Right, Anichi? You're going to put that away? Land moves even slower than that. So our last one, transforming plates. Show me with your hands. What does this form? Everyone should say it. Earthquake. So these plates, this is what happened in Japan. Plates, remember I showed you. We go back to our map of the plate boundaries. Remember Japan is kind of over in this area where the Indo-Australian plate is and the Eurasian plate, sort of. And that's because those two plates rubbed up against each other. They transformed. And so this is where you can actually feel the land move. This is the only time you can feel the land move because it happens so suddenly. It's like a jerk. Have you ever had your knee jerk out from under you?
Yeah.
Yeah? That's what it kind of is like. It's like the plates jerk and move. And and you can feel it. So if we look here, plates transforming. If I were a building and I were standing right here, what would happen when they move? Yeah, the building would shake. So if Serena Hills was on top of a plate and the plate transformed suddenly, you would feel the shaking because those plates would move.